Now we are going through exercises on Lesson 3, Radioactivity and Nuclear Energy. Open the books, page 52. Choose the correct answer for each sentence. The radioactive phenomenon was discovered by the scientist Ohm, Becquerel or Ampere Becquerel. The space effects of radiation is the result of changing the sex chromosomes of the cells, physical, genetic, or cellular genetic effects. Those who work with radioactive elements should not be exposed to radiation in amounts more than 5, 8, or 10 millisievert yearly. In this question, there is a mistake, because now we know that those who work with radioactive elements, they are allowed to be exposed to radiation in amounts till 20 millisievert yearly. More than 20, they are not allowed to be exposed. Number 20, we don't have it in the options. Question D. Space is a non-radioactive element. Radium, uranium, or iron. Iron is a non-radioactive element. The measuring unit of absorbed radiation is the sievert. The answers about give reason and write the scientific term, you'll find them on the next page. Give reasons. The areas chosen for storing radioactive wastes should be more steady to prevent the spreading of the radioactive wastes in the surrounding environment by the effect of earthquakes or volcanoes. Radiation has genetic effects because the radiation pollution can affect sex chromosomes composition, which result in abnormal birth. After the Chernobyl accident, radioactive isotopes were found in the food products. Question C. During the Chernobyl explosion, the radioactive elements formed a cloud, and when the rain fell, it carried all the radioactive elements to the Earth's surface. The plants and soil were polluted. Animals which ate these plants were polluted, and therefore their milk and meat were polluted by the fallen radioactive elements, isotopes. D. Radioactivity has natural sources and also artificial ones, because the radioactive elements present in nature are all the time in an attempt to achieve a more stable composition automatically. Natural radioactivity, we call this. Also, the radioactivity has artificial sources because of the nuclear reactions, either from nuclear reactors or from nuclear bombs. E. Some elements are called radioactive elements because the atom's nuclei of these elements contain a number of neutrons more than the number required for their stability. Write a scientific term. The process of spontaneous decaying of atoms of some elements present in nature to reach a more stability. Radioactivity phenomenon. Question B. The radiation and nuclear energy emitted during nuclear reactions that can be controlled and carried out at nuclear reactors. Artificial radioactivity. Peaceful uses of nuclear energy. C. The changes that take place to the living organism due to its exposure to radiations. Physical effects. D. The measuring unit of the absorbed radiation is called sievert. Now we are going to carry on with a revision on Unit 2, Electric Energy and Radioactivity. Open the books on page 54-55 on exercises. The scientific term, you'll find them on the next page. Let's carry on, we choose the correct word. Direct current can be produced from electrochemical cells, electric generators, or electric power stations, electrochemical cells. B. The space is the measuring unit of the electric charges, coulomb, ampere, or volt. Coulomb is the measuring unit. C. The space is the measuring unit of the electromotive force, coulomb, ampere, or volt. Volt is the right answer. Question D. The space is used to measure the electric resistance, ammeter, voltmeter, ohmmeter. Ohmmeter is the right answer. E. The space is the measuring unit of the current intensity, coulomb, ampere, or ohm. Ampere F. The mathematical relation of Ohm's law is resistance equal potential difference over intensity. Question G. You should not be exposed to radiation more than space millisievert yearly. In this question, there is again another mistake, because we as a public, we are not allowed to be exposed to radiation more than 1 millisievert yearly. Number 1 doesn't exist in the options that the exercise is giving. Write scientific term on page 54. The flow of electric charges in a conductor is called electric current. B. The electric current of constant intensity and direction. Direct electric current. C. The resistance of a conductor that allows the passing of an electric current of 1 ampere through it when the potential difference between its two ends is 1 volt. The ohm. D. The intensity of the electric current flowing in an electric circuit when an electric charge of 1 coulomb passes within the conductor's cross-section in 1 second. The ampere. E. The device used to measure the intensity of the electric current passing in a conductor. Ammeter. F. The electric state of a conductor that shows the transference of electricity from and to it. The electric potential of a conductor. G. The measurement unit of the electromotive force of the electric cell is volt. H. The measuring unit of the absorbed radiation is sievert. The natural decaying of the atoms of some elements in nature is an attempt to reach a more stable composition, radioactivity phenomenon. Let's carry on with give reasons on page 55. It is better to use the alternating current rather than the direct current, because it can be transferred for long distances and it can be changed into a direct current. B. The voltmeter is connected to both poles of the battery in the electric circuit to measure the electromotive force of the battery. C. Rheostat is used in some electric circuit to control the electric current intensity in the electric circuit and the electric potential difference between its ends. D. Some cells are connected in the electric circuit in series. Y. To obtain a battery with high electromotive force. E. Some cells are connected in the electric circuit in parallel to obtain a battery with low electromotive force. F. The electromotive force of a battery whose cells are connected in series is greater than that one whose cells are connected in parallel. Why? Because the electromotive force of the cells connected in series is equal to the sum of the electromotive force of these cells, while in the parallel connection the electromotive force of the battery is equal to the electromotive force of one cell. G. Some elements are called radioactive elements because they are elements whose atoms nuclei contain a number of neutrons more than the number required for its stability. H. Radiation has genetic effects because the radiation pollution can affect sex chromosomes composition, which result in abnormal birth. And like this, we finished all the give reasons. Let's carry on with the fourth question. The fourth question says, calculate the potential difference between the two ends of a vacuum cleaner whose resistance is 22 ohms and the current intensity passing through it is 10 amperes. So what is given is resistance 22 ohms and the intensity equal 10 amperes. What we don't know and we are going to find is potential difference. Solution. Based on Ohm's law, which says that the resistance is equal potential difference over intensity, we can log out the potential difference. Once we log out the potential difference, the new relation is going to be V equal R times I. Potential difference is equal resistance times intensity. Now we have both values, we have resistance and we have intensity. So our potential difference is going to be 22 times 10 equal to 120 volts. And let's go on with the last question on page 55. Question 5 says you have 4 similar electric cells. The potential difference of each one is 1.5 volt. Illustrate by drawing how you can connect them to get batteries of electromotive force of 6 volt, 4.5 volt, 3 volt in 2 ways, and 1.5 volt. So we have 4 similar electric cells and we want to connect them in different ways to get different results. So, for the first case, to get an electromotive force battery of value 6 volt, we are going to connect them into series, because we said if we connect the electric cells into series, the electromotive force battery is going to be equal the sum of the electromotive force of all cells, or N times E1. N is the number of cells, E1 is the electromotive force of one cell. So the electromotive force of battery is going to be 4 times 1.5 equal 6 volt. Now we need to get an electromotive force battery equal 4.5 volt. In this case, we are going to connect 2 cells in parallel and the third and the fourth in series with the first 2 ones, because we learned that if we have cells in parallel, the electromotive force battery of the cells in parallel is going to be equal to the electromotive force of one cell. So these 2 cells are going to give us the value of only one electromotive force cell is equal 1.5 volt. So electromotive force battery is equal E1, which is the value for both cells, plus E3 plus E4. Electromotive force battery in this case will be equal 4.5 volt. The third case wants an electromotive force battery equal 3 volt to be connected in 2 ways. I'm going to show you the first way. The second way is going to be your homework, and also the point D is going to be your homework. So, to get an electromotive force battery of the value 3 volts, I'm going to connect the first 3 cells into parallel, and the fourth one will be connected into series with the first 3 ones. So, if I connect these 3 cells into parallel, the value of the electromotive force of this battery here is going to be equal to the electromotive force of one cell, equal 1.5 volt. So, like this, electromotive force battery is going to be equal electromotive force of the first cell plus electromotive force of the fourth cell. In this case, the result is going to be 3 volt. Again, the second way for the point C and the point D are going to be your homeworks. Thank you for watching.